Hello everybody, today I'm back with another video, and today I'm going to be covering the definition of the derivative, and this video is about calculus. This is a topic in calculus AB and BC, so whichever one you're taking, you'll probably need it. If what happened during the 2020 AP exams, well, if the same thing happens again where they have to cut content, if a similar thing happens, this will probably be on the exam as well. This is in the 2020 AP exam curriculum, but I don't know how relevant that is anymore. So either way, let's get right into it. And the definition of the derivative, so basically, what is the derivative? So basically, this gives a mathematical definition. This is, I think, a mathematical definition of the derivative is a bit more accurate. So let's just draw a simple graph. It's not going to be the best because I'm not the best drawer with this thing. I'm using my mouse pad for this. So this is like you got your x-axis and your y-axis. I would put the arrows, but I think I'll just mess them up more than show you that it's an arrow. And let's say we have just some arbitrary curve. Let's draw it in a different color. Alright, let's fix the line. Okay, that's not the best, but it'll do. And let's say we got like this curve right here. So the derivative, let's say we wanted to find the derivative at a certain point. Well, you'd first have to ask yourself, well, what's the derivative? A derivative is the slope at a certain point, the instantaneous rate of change. So your calculus teacher may refer to it as IROC, which is just an acronym for instantaneous rate of change. One thing you may have heard in a lot of other contexts is called AROC. And what AROC means is average rate of change. And you're probably more familiar with this term since you probably used it when you did linear equations. You have probably seen it when studying for the SAT, if you've gotten to that yet, or the PSAT for that matter. ACT as well. If you've taken the math subject test, that as well. If you've taken pretty much any algebra class, you've probably seen AROC. Maybe not IROC though. But what the definition of the derivative wants to show you is that AROC is equal to IROC. And let me rewrite this. AROC equals IROC. Now, since the derivative is IROC, I mentioned that earlier, and so if you know AROC, you can find the derivative at a point. So let me take blue right here. So if I wanted to find it, I could like draw a tangent line with the slope. As you can see, right there, it'll be tangent to the curve at this point. I know it looks kind of close, but that's just because I'm a bad drawer, not because it'll actually do that. So once you have IROC is equal to AROC, what do you do from there? What is AROC? You probably, if you have some recognition with this, you may realize that AROC is the slope formula. What's the slope formula? You may have forgotten, but I doubt it because it's kind of common. It shows up in pretty much every math class before calculus. So maybe not like trigonometry though. So like, oh goodness, my mouse went crazy. So y2 minus y1 is equal to, over x2 over x1. So that's our slope. Solving this will get us the slope. But how do we solve for this if we only have one point to work with? Essentially what I'm saying is that y2 and y1 are the same, x2 and x1 are the same. So first let's try to solve this. Solve this in your head, maybe. Try it out. What will it be if y2 and y1 are the same, x2 and x1 are the same? So what'll happen? You'll get y2 over y1, which, as I mentioned, is the same. You'll get 0 on the top. x2 minus x1, 0. If you've covered limits yet, which I hope you have, I might post a video on it. I haven't done any limits videos yet, but you can certainly find it in other places. So you get 0 over 0, and whenever you get 0 over 0, you should be wary. Like if it came out as 1 over 0, then you may have a bit you might have a bit of a problem. But if you have 0 over 0, that means there's something you can do. Now, what's that something you can do? You can use a limit. Now, if we were to use a limit on this, and let's try to bring this into some better terms. Instead of using y, let's use f of x. So f of x, we're going to use f of x instead of y. And what we're going to do is, let me clear this out and clear all the rest out. So keep in mind we got 0 over 0 before, and what I crossed, so I accidentally took some of that out. Anyway, so what you can do, this is a bit long, give myself some space. This is the x-axis, and we have the y-axis. So with this, what can we determine? We can take both of the points, okay, and both of the points are going to be, well, they're the same point in this case. So we have the limit, lim is the term, as x approaches something, and I'll explain what that is. Actually, we're not even going to put in x here, and I'll explain why. So we're going to have f of x minus f of x, right? Now, let's try to revisualize this, because it'll just give us the same answer every time. What if I were to look at this a bit differently? What I'm saying is, what if, well, let's reiterate, actually, let me restate that. What is a limit? A limit means something approaches something. Very basic, very rudimentary, but it basically means that something is approaching some value. So if something is approaching some value, let's say we have a point x plus h. So we have our point x. Okay, we'll say x1 actually to make sure we don't confuse it with the x-axis. And we'll say here is x1 plus h. So with that, we can, let's redraw our graph here. So it's something like that. So you can take both of these and you can try to solve for, it does not want to go over. So you can see it kind of intersects there, but whatever. It'll actually become a secant line. A secant line is where it actually crosses the line on two instances. Here you can see it at x1 and x1 plus h. What we want from a derivative is a tangent line. We want it to cross at only one point. But what we can do with the limit is make h become small. If you have x1 over here, x1 plus h, and let's say h becomes 0. As h is becoming 0, you'll notice that it becomes closer to x1, which means that they'll become the same point. Now this is something I want you to understand, so if you need to play it back a few times, feel free to do so. After that, let me erase some of this here. Alright. So what we can do, I'll write x1 for simplicity. X1 plus h. So if, to reiterate what I said in mathematical terms, and I'm doing it right here, we're going to put h here, not x as I was doing before. And we're going to put 0. And c, and I'm going to write it down, and I'm going to explain it after. And we got x1. We have x1 minus, x1 plus h x1. So that's what we get so far. So with that, what can we determine? Well, if I were to just plug in 0 as is, I wouldn't really get much. I would really just get the same thing. I'd get 0 over 0. That's the first thing you want to do with a limit. You just plug it in to the function. If I plug in h0, I put it here, we get f of x1 minus f of x1, which is just 0. We'll get x1, and then this is h is 0, and then we just get x1, sorry. So with this, we don't really get much as it seems, but in reality, this is the definition of the derivative, in that you can simplify what you have up here. For example, you can take a function, let's say f of x was x squared, for example, and you could take that and you could solve for a certain thing, and you'd get a simplified version where even though h is 0, it doesn't necessarily turn out. I could solve a function. I could solve an example like this. Let me solve an example like this. So let's say we have the limit as h approaches to 0, and we have the limit as h approaches 0. Sorry for the background noise. We are going to, let's say we have x squared, as I was saying before. So let's say we have x plus h squared, and I'm just going to write x for simplicity. And we're going to have minus x squared. On the bottom, we're going to have just the same things, really. x1 plus h minus x, oh, maybe not x1. I forgot of my own rule. So x plus h squared, if we factor that out, it's going to be x squared. We're going to have h squared, and we're going to have 2hx, and then you're going to have minus x squared at the back too, so this term will cancel out. So you'll just be left with this. You'll also notice that these x's cancel out. X1 plus x plus h, I don't know why I wrote h1, x plus h minus x is equal to h on the bottom. You'll have h on the bottom, and you'll notice that it cancels out. So you'll notice that this h cancels out, and this cancels out. So you have 2x plus h. Now try putting in the limit. And by the way, one mistake I made, I'm supposed to put the limit, you see where my cursor is? I'm supposed to put limit as h approaches 0 on every step. Make sure you do this, your teacher might take off points for it. I didn't do it, because it was kind of an accident, to be honest, but do remember it when you are doing it yourself. I'm sorry I didn't include it here, but I'm going to write it down right now. I think there's a button in the way. Limit as h approaches 0. Now you'll notice that if we plug in 0 here, you'll get just 2x. And if any of you know anything about a derivative yet, like a how to solve the derivative. Maybe if you know the power rule, maybe you've watched my videos on that. You'll know that if you take the power, the derivative of x squared, which is the function that we were using for this example, you'll get 2x. And that is what we got here, therefore proving that in this case, the definition of the derivative worked. Try this for a few of your own functions, maybe mix it up a little. I'm sure your calculus teacher will also give you some really nice functions to work with when you're doing the definition of the derivative. Anyways, guys, thank you guys so much for watching. Be sure to subscribe if you haven't already, and please leave a like if you haven't already as well. If you want to see more of calculus, then please leave that suggestion in the comments down below. Otherwise, thank you guys for watching, and I'll see you in the next video. Bye.